Every year, more than 90 million tons of aluminum are consumed, and out of that, 41 million are recycled. But do you know how recycling is done? In this video, you'll see all the stages of the industrial aluminum recycling process, from the initial sorting of scrap to the casting of new ingots. It all starts long before the furnace fires at the collection and sorting stage. The aluminum that arrives at recycling plants comes from two main sources. The first is what's called post-consumer scrap, which are the items we use in our daily lives, like beverage cans, food trays, spray containers, and parts from old appliances. The second source is industrial scrap, made up of leftovers from manufacturing processes, such as scraps from airplane sheets, leftover window frames from construction, or trimmings from automotive parts. When these materials arrive at the receiving centers, they form real metallic mountains that need to be organized, because not all aluminum is the same. There are several different alloys, some more flexible and others more rigid, and mixing them in a disorganized way can complicate the melting process. Sorting is a separation process, a physical separation, that uses large machines to clean the load. Since aluminum is not magnetic, the industry uses this fact to its advantage, where giant magnets remove any piece of iron or steel that may have come mixed in. Right after that, a piece of equipment called an eddy current separator comes into play. Basically, this machine creates a magnetic field that interacts with the aluminum, pushing it off the conveyor belt, while the plastic, glass, and wood simply fall by gravity in another direction. It's a precise mechanical dance that ensures only the desired metal moves on to the next step. Once isolated, the aluminum needs to be prepared for the heat. Imagine that a soda can is very thin and is covered with paints and varnishes on the outside. If we throw that can directly into an industrial furnace, the paint would burn and create thick smoke, and it would also oxidize the metal, causing a lot of it to be lost. That's why the material goes through a shredder, which reduces the pieces to fragments the size of a coin or small pieces of shredded paper. This fragmentation process increases the surface area of the metal and makes it easier to remove impurities. These small flakes of aluminum are then taken to a paint removal or coating removal machine. It's an extremely hot air tunnel, but without direct flames that blows heat over the fragments, so that the paints and plastic coatings vaporize and come off, leaving the metal clean for melting. The aluminum, broken up and cleaned, is transported to huge furnaces that operate at temperatures around 700 degrees Celsius. At this temperature, the solid aluminum turns into a shiny silver liquid, very similar to the mercury we used to see in old thermometers, old ones, but in a volume of tons. There are different types of furnaces. Some are rotary and spin like giant cement mixers to make sure the heat is distributed evenly, while others are static and have sidewells where the metal is loaded. During melting, an inevitable byproduct appears, called slag. Slag is a layer of dirt and oxidation that floats on top of the molten metal, like the skin that forms on boiled milk. Skilled operators use long tools to skim this surface, removing the impurities so that only pure aluminum remains at the bottom. The environment in one of these industries is marked by intense heat and the constant noise of conveyors and shredders. The operators work wearing aluminized protective clothing, which reflects the radiant heat, because being near a pool of molten aluminum is like standing next to a small artificial star. However, behind all this brute force and scorching heat, there is surgical precision. At this stage of liquidity, one of the most important moments occurs technically, the adjustment of the alloy. As mentioned before, the aluminum used in an airplane wing needs to be much stronger than the one used in a soda can. If the industry wants to produce a specific type of metal, chemical engineers need to collect a sample of the liquid and take it for immediate analysis in a spectrometer. If the result shows that a bit of magnesium, silicon, or copper is missing to achieve the desired hardness, these elements are added directly to the molten metal. It's like seasoning a soup on an industrial scale, where every gram of additive changes the final behavior of the material when it cools down. With the chemistry properly adjusted, the liquid metal needs to be turned solid so it can be transported and sold. This process is called casting. The molten aluminum leaves the furnace through heated ceramic channels and is poured into molds. Depending on its destination, it can become an ingot, which is a heavy and robust block of metal, or a billet, which looks like a long cylindrical post. In some more modern plants, the aluminum doesn't even cool down completely. It is kept liquid in giant thermal crucibles, which take the molten metal directly to neighboring factories that produce automotive parts, saving the energy that would be spent melting it again. Although the process seems simple in theory, keeping a furnace running 24 hours a day requires strict temperature control and a very sophisticated gas exhaust system. To ensure that the waste from burning paints doesn't heat up when disposed of, paint waste is disposed of. Because of this, the industry deals with the challenge of metal loss. Every time aluminum is melted, a small part of it oxidizes and turns into dross, which can't be used immediately as pure metal. The efficiency of a recycling plant is largely measured by its ability to minimize this loss and recover as much metal as possible. From each load of scrap that comes in, if the final goal is to produce waste, new sheets for cans or thin parts, the giant ingots, which can weigh up to 20 tons, go through a process called rolling. Imagine a rolling pin, but made of solid steel and exerting pressure of thousands of tons. The hot aluminum block is passed through these rollers several times, becoming thinner and longer each time. At the end of this production line, what was once a solid block of metal is transformed. A coil of aluminum sheet, several kilometers long, is rolled up as if it were a roll of kitchen aluminum foil. But on a colossal industrial scale, these coils are the final product of recycling and the starting point for the manufacturing of new items. What makes this process fascinating for those who observe the industry is the response time. In the case of aluminum cans, for example, the complete cycle, from the moment the can is thrown in the trash, goes through collection, is melted down, turned into a coil, becomes a new can at the beverage factory, and returns to the supermarket shelf. It can take just 60 days, in fact. For the end user, it's impossible to tell whether the aluminum is from their computer or their bicycle. It came from a mine or from a can that was discarded months ago. And that was today's video. Don't forget to leave a like and subscribe to the channel.